Hey guys, welcome back for the third review video. I'm going to be talking about three variable systems by hand. I'm not going to talk a whole lot about the calculator portion. Just if you don't know how to type in the calculator, reach out to me and say, hey, can you make me a quick 2-minute video on how to type it into the calculator? And I'd be more than happy to remind you. And then I'll be talking about some matrix equations, and I'm actually going to go ahead and move into the fourth page of the review because it doesn't have a whole heck of a lot. In fact, the only topic on it is finding the area of a triangle, which is kind of like Cramer's rule. It's a rule about how to use determinants. Okay, so starting off, I had said this in the last video, but I'm going to say it again. The questions on the test about three variable systems that you need to solve by hand will not be on the calculator portion. You will not get a calculator for these. You will get a calculator for this part. Okay? That means I need to see all of your work for these two. Now, you'll notice that these two are nicely set up so that it only has y and z. Your ones on the test will be exactly like this. So what you need to do first is eliminate y or z, whichever one's easier, between these two equations. Well, guess what? This one's already ready to go. Over here, you'll need to multiply to make this happen. Over here, you don't, because you already have negative 6z and 6z. So if I add these together as is, then it's going to be 7y equals 14. Divide by 7 on both sides, and we get y equals 2. The only part that's a little bit tricky about this one is you have to plug in y now, but you cannot plug it back into the top equation because we don't know what x or z are. Instead, you can plug it back to any of these two that only have y and z. I'm going to pick the first one, the second row, sorry. I'm going to plug in 2 right here for y. So that's going to become 5 times 2, which is 10. Minus 6z equals negative 8. And then I need to subtract this 10 to the other side. Well, negative 8 minus 10 is negative 18. And now I divide by negative 6 on both sides, and I get 3. And then last but not least, I have to find out what x is. And to find out what x is, I need to use the top equation because it's the only one that even has x. So it's going to be 2x plus, and then I'm going to multiply 4 times 2, because that's what y is, so 8. And then negative 7 times 3, because that's what z is, would be negative 21 equals negative 11. Well, 8 minus 21 is negative 13. So then now I can add the 13 to the other side. I get 2x equals 2, so x equals 1. Y equals 2, and z equals 3. Okay, moving on. The third thing that you need to know is how to solve equations involving matrices. Think of them like regular equations. For instance, on this one, you have x minus negative 6 equals, since we're in the top right, 2. Just be careful. Make sure you're looking in the same spot of each matrix. Okay? So that really is x plus 6 equals 2, so you need to subtract the 6 on both sides. Negative 4 plus 6 equals 2. And then you would do the same thing for y, but it's in the bottom right. So 4 minus y equals negative 6. We're going to subtract that 4. That will make this negative 10. And then we need to divide by the negative that's in front of y, so y should be positive 10. And hey, 4 minus 10 is negative 6, so we're good to go. And then you would do z, which is in the bottom row left. Negative 3 minus 2 equals z. Well, negative 3 minus 2 is negative 5. Okay? And then over here, just make sure you find the determinant like normal. So this will be 20 minus negative 3x equals 2. Don't forget that you just find the determinant like normal. Now I'm going to go ahead and make this a plus because it's minus a negative. So subtract the 20 to the other side and divide by 3. Okay, this one only has an x. I don't know why it has an x, a y, and a z. Actually, I do, because I had originally put 2 of these. And then realized I forgot a determinant one. Okay. Right here, act as if you're solving for the variable. So this is being subtracted. The only way to get rid of a matrix that's being subtracted is to add it. So I'm going to add it to the other side. Okay, and I'm not actually going to write it twice because that's kind of a waste of effort. So then you're just going to add it over here. Again, I'm adding because that's the opposite of subtracting. And you're going to get 3x equals 5 plus 1 is 6. 1 plus negative 7 is negative 6. And I'm going to go ahead and pause for a second and just remind you, when you're adding and subtracting matrices, you're not flipping or flopping or moving anything around. It's just very direct. Negative 11 plus 2, because those are in the second row, first column. 13 plus negative 1. 13 plus 5. And 27 plus negative 3. And then guess what? You need to get rid of that 3 in front of x. So we're going to divide by 3 on everything. So x is a matrix, and it equals 2, negative 2, negative 3, 4, 6, 8. Because I literally just took all those numbers and divided them by 3. This equation is very similar, except for since it's adding, you will subtract this matrix to the other side. And then you have these two left down here. Notice how there's nothing in between the matrix and y. That means they're being multiplied, kind of like on the last page. The only way to get rid of a matrix that is being multiplied is to multiply by the inverse. Okay, so I'm going to find the inverse of this one. This is the problem I'm going to do with you guys. I'm not going to do the one on the left. And the inverse is 1 over the determinant. So 12 minus 15, which is negative 3. And then for the matrix, you're going to switch this first diagonal. So the negative 6 goes up here and the negative 2 comes down. And then the other diagonal switches signs. So they both become negative. And then I'm going to multiply that by the other matrix. Okay, and then I'm going to do a little bit of work in my calculator on this one in a second. I am not going to deal with this negative 1/3 yet, because I'm going to get some weird fractions, and I don't want to deal with weird fractions right now. So I'm going to take that first row times the first column, which means I'm going to do negative 6 times 5 plus negative 5 times negative 3. So I'm multiplying the first two and the second two. And that's negative 15. And then I'm going to move to the next column, and the negative 6 gets multiplied by the negative 9, plus negative 5 gets multiplied by the 12. Negative 6. And then here, negative 3 times 5 is negative 15, plus negative 2 times negative 3 is 6. Notice how I'm adding the two answers together, not subtracting them like you do with determinants. And then negative 3 times negative 9 is 27, plus negative 2 times 12 is negative 24. Then you need to do that negative 1/3. So negative 1/3 of negative 15 is positive 5. Negative 1/3 of negative 6 is positive 2. Negative 1/3 of negative 9 is positive 3. And negative 1/3 of positive 3 is negative 1. You're basically dividing all of these by -3. Okay, let's flip to the last page of the review. The last thing you need to know for your test is how to find the area of a triangle using determinants. Okay, so you're going to multiply 1/2 times the determinant of 3 by 3 matrix with the points. And then one thing that you're going to have to add is a column of ones at the end. Right, so for instance, this first one, 2, 7, 5, 1, 10, 3. And then you add a column of ones at the end always. Basically, you're adding a column of things that don't change multiplication, and ones don't change multiplication. The zeros would make everything 0. And then you're going to find your determinant by copying the first 2 columns, like this, and then you're going to multiply these. That's going to be 2. 7 times 10 is 70. 3 times 5 is 15. And then add those all up. That is 87. And then you're going to do the same thing on the left. 10, 6, and 35. Add those all up, that's 51. And you subtract your answers. The right one minus the left one, that's 36. So the area would be 1/2 of 36, which is 18 units squared.